On January 18, 2024, with its 72nd flight, the mission of the small Ingenuity helicopter came to an end. Unfortunately, something went wrong during the landing phase. One of the blades broke, marking the conclusion of a mission that had surprised and won the hearts of millions of space exploration enthusiasts. After more than 2 years of extraordinary feats on Mars, we had grown attached to this little flying robot. Originally, its mission included only 5 experimental flights, but in the end, it accompanied us for 2 years and 9 months, completing a total of 72 flights and setting new standards for planetary aerial exploration. Ingenuity was the first aircraft to fly on another planet, a milestone in space exploration. Now that its adventure has come to an end, it's time to reflect. Why was it so difficult to fly a helicopter on Mars? And what were the tangible outcomes of this mission? We will discuss this in detail in this video. Ingenuity arrived on Mars in February 2021, carried aboard the Perseverance rover as part of NASA's Mars 2020 mission. The small helicopter was attached beneath the rover's belly, and once they landed in Jezero crater, Perseverance gently released it onto the Martian surface. From there, the rover moved about 100 meters away to avoid any unexpected damage from Ingenuity's experimental flight. On April 19, 2021, Ingenuity made its first flight, a historic moment marking the first flight of an artificial object on another planetary body. Initially, the mission included only 5 flights over the span of 30 Martian days, about 31 Earth days, but the success of the early flights allowed the mission to be greatly extended. In the end, Ingenuity completed 72 flights over nearly 3 Earth years, far exceeding initial expectations. The small drone demonstrated that it is possible to fly on Mars despite the planet's harsh atmospheric conditions. Its structure was rather simple, a lightweight box of compact dimensions, 14 by 20 by 16 centimeters, with 2 counter-rotating rotors measuring 1.21 meters in diameter. The whole system was powered by a solar panel and supported by 4 slender legs. Inside, Ingenuity was equipped with 2 cameras, one for autonomous navigation and the other for taking images and sending them back to Earth. Although Ingenuity was initially designed for short flights of about 90 seconds at an altitude of 3 to 5 meters, it surprised everyone by flying for a total of 128 minutes and covering a distance of 17 kilometers on the Martian surface. It made an extraordinary contribution to the mission, helping scientists and engineers gather crucial data for future robotic and human exploration on Mars. But why was flying on Mars so challenging? Flight on Mars presents unique challenges, mainly due to the planet's thin atmosphere. The atmospheric pressure on Mars is about 1/100th of that on Earth, meaning there is much less air to create lift, the force that allows an aircraft to rise against gravity. To understand this better, think of airplanes on Earth. They generate lift through the shape of their wings and the airflow that moves above and below them. But on Mars, with so little air available, generating lift becomes a massive challenge. To overcome this obstacle, NASA engineers designed Ingenuity to be incredibly light, weighing just 1.8 kilograms. Moreover, Ingenuity's rotors spun at about 2,800 revolutions per minute, much faster than the rotors of a helicopter on Earth, which rotate at about 400,500 revolutions per minute. This increased rotational speed compensated for the lack of atmospheric density on Mars, allowing the small helicopter to fly. Despite all the difficulties, Ingenuity exceeded every expectation, not only successfully completing its experimental flights but also providing crucial information for future Mars missions. Its success led NASA to modify its plans for the future collection of Martian samples. Initially, Perseverance was supposed to deposit the samples to be retrieved by another rover in a subsequent mission. However, after Ingenuity's success, NASA decided to use 2 small helicopters similar to Ingenuity to collect these samples, highlighting the key role that aerial flight could play in future Mars exploration. The experience gained from Ingenuity paves the way for new possibilities in the exploration of Mars and other planets with thin atmospheres. Aerial flight on Mars offers a unique perspective. It allows the exploration of areas difficult to reach with rovers and provides an overview of the terrain, which can be critical in planning future missions, both robotic and human. Beyond its scientific contribution, Ingenuity's mission demonstrated that even experimental technologies can have a tremendous impact on planetary exploration. The small helicopter blazed new trails, showing that aerial exploration is not only possible on other planets but could become an essential tool for the future. The Ingenuity mission showed that aerial exploration can overcome seemingly insurmountable obstacles, and its success laid the groundwork for future technological developments. The fact that NASA chose to use 2 helicopters to collect Perseverance's samples is a testament to the value of this technology. Additionally, Ingenuity provided valuable data not only for science but also for the design of future missions, bringing the dream of a human presence on Mars a little closer. Thanks for watching. Remember to leave a like and subscribe to the channel to support us.